Welcome to all students. Today in FEM we discuss about what is FEM, what is use of FEM, what is are the applications of FEM, what are the advantages of FEM. So the FEM define an infinite element method. The structure to be analyzed is subdivided into mesh of finite size elements of simple shape, and then the whole structure is solved with quite easiness. So the application of FEM is the FEM has been successfully applied to solve several types of engineering problems, like extensive studies have been carried out in mechanical, civil, biomedical, electrical, nuclear and chemical, hydraulic, aerospace and aeronautics engineering problems. The specific application of the FEM can be grouped in two categories, namely equilibrium and eigenvalue problem. In equilibrium problems like aerospace engineering, automobile engineering, biomedical engineering, civil engineering, electrical engineering, hydraulic engineering and mechanical engineering and nuclear engineering. So this is the FEM application. In finite size elements, the rectangular panel in the rectangular body and triangular panel in the circular plate and refer to an element. There are 1, 2 and 3 dimensional elements. The accuracy of solution depends upon the number of finite elements. So in finite size elements, there is some important terminology in finite element terminology like domain. A domain is a continuous mass consisting of a sequence of particles of materials such as solids, liquids or gases rather than as a discrete mass. This means that the matter in the body is continuously distributed and fills the entire region of space it occupies. Domain also refers to continuum of a particular interest. Node. A node is a specific point in a finite element at which the value of the field variable is to be determined. These are points where properties are to be determined for an element. Element is the joining nodes and forming a specific shape such as bar, triangle or quadrilateral is known as finite elements. In degree of freedom, minimum number of parameters that is motion, coordinates, temperature required to define position of any object in space completely is known as degree of freedom. In loads or forces, the internal forces are introduced through the concept of body forces and traction forces in addition to point forces. Body forces are those which act on every particle of the body, that is over entire volume of the body, and are specified in terms of per unit of mass per unit of volume of the body. For example, magnetic forces and gravitational forces are the distributed of the body forces. So, if an uniaxial bar is part of structure, then it is usually modeled by a spring element if and only if the bar is allowed to move freely due to the displacement of the whole structure. This is one dimensional element. In types of elements, here goes the example of 2 and 3 dimensional finite size elements. In node, the points of attachment of the element to other parts of the structure are called nodes. The displacement at any node due to the deformation of structure is known as nodal displacement. Why FEM? It is very important. Why FEM? Simple trusses can be solved by just using the equilibrium equations. But for the complex shapes and frameworks like circular plate, equilibrium equations can no longer be applied as the plate is an elastic, not the beams or bars as the case of normal trusses. Hence, metal plate is divided into finite subdivisions. In finite element method, FEM makes piecewise approximation. It ensures continuity at nodes as well as along the sides of the element. In solution can be obtained at the nodes as well as any point within the field using shape functions. It needs less number of nodes to get good results. It can handle complex problems. It considers boundary shape as it is. So FEM, there is today we discuss about all basic things. Like this method is a numerical method to obtain approximate solution. Can be solved easily. Non-linear problems can be solved easily. In FEM, the solution is obtained for each node and element. FEM can handle any entropic and non-homogeneous properties. So, today we cover all of these points in this basic of FEM. So, FEM is a very important topic. So, thanks all of you.